Yeah. All right. Okay. Yes. Yeah, I'd share two photos in the WhatsApp group regarding the IC engine connecting rod. So yes, so one of them is here. Uh, Here you can see the entire assembly of a connecting rod with a piston and its rings. Okay, but for the syllabus, you don't have this particular part, the piston and its ring, the extreme right hand side. That particular portion is not there. Okay, that's a different assembly. We have to assemble only the connecting rod. There are so many other parts that has to be assembled before this connecting rod has been fitted to the crankshaft of an engine, right? So for this, if you take up a connecting rod here, it is been it is indicated. So we have the connecting rod over here, okay, and then onto the left side the half semicircle with other portions of it. We have the part number 2, which is the cover, okay. Then for both of these to be joined, okay, we need to make use of a stud nut, okay, then with nuts, studs, then nuts, and for that the pin, there's a washer, okay. Only then this connecting rod and the cover where the crankshaft is going to come into place will be locked, okay, right? And in this circular portion where the crankshaft is going to come in place, we need to have a free rotation because the connecting rod is going to help uh, in in converting reciprocatory motion to rotatory motion. So we need to make use of a bearing. Okay, so bearing brasses of two numbers are over here. So two halves of the bearing have to be assembled over here, which is at the big end of the connecting rod. Okay, and then between this cover and the connecting rod, there's a distance piece. Okay, that is nothing but like a block of solid rubber or metal, generally a metal only. Just a second. Yeah, it is made up of metal. Okay, so that will be placed over there to form a tight seal, okay, between the cover and the connecting rod, right? So even this has to be assembled properly. Then for this connecting rod, this is one of the drawing portion where we need to make use of an oil hole for lubrication purpose because we have a big end bearing sitting in the connecting rod, right? So like this, we have several parts on one side of the connecting rod. Similarly, if you look at the uh, small end of the connecting rod that is onto the right side, forget about the piston and the ring. So this piston ring, this is not there, this is a different assembly, right? We'll have a small end bearing and other things over here, okay, right? So we have to make all these parts in 3D module, that is in solid part, okay, and then assemble this connecting rod, okay, right? Is that clear? Any doubts? Hello?
No,
Any
sir.
doubts? Right? Okay. Right. Okay. Now let us. So we have to make this entire assembly of the connecting rod. Now we'll see the parts and its details. Okay. So this particular part details will be given even in the exam. Okay. And one more thing, as I've already mentioned, as I've already told several times, uh, they will never give how the assembly will look. Okay. In part C question, that is for assembly drawing question, they will never give how it has to be assembled. The assembled view will never be given. They will only give the parts. Okay, the details of the parts will be only given. Only this particular thing will be given with bill of materials. Okay, right. Okay, so now if you look at this, uh, so now we have totally of 10 parts over here. So connecting rod, bush, stud, pin, bearing brasses. Okay, then distance piece. That is the one that is going to fill the gap between the connecting rod and the cover. Okay, and then we have the cover, washer, nut, split pin. Yeah, right. And what is the material is been given in the next column. And in the last column, how many number of pieces is required for one assembly is given. So for connecting rod, we need one connecting rod, bushes is one, then studs are two, two pins, bearing process two, and so on. Right. Okay. So now if you look at this, yes, we have the connecting rod over here, part number one, whose front view and sectional view and top view is given over here. Okay, and we have the cover onto the left side. Sorry, yeah, cover onto the left side, part number 7. Yeah, and the other details of the parts or other part details are also given. Yeah, so we'll see one by one today how to do these drawings. Yeah. Okay. Just a second. Okay. So here part number 2, that is the bush. So they have given a sectional view of that. So you can see there is hatchings on both the sides. The outermost edges are indicated with the dimension diameter 18. That means it's circular in diameter, and we can see some thickness for this bush. So the side view for this is given here onto its right side, whose inner diameter is 12.7. Okay, and here onto the circumference of this, there's a oil hole of diameter 2, and there's a groove which is for 2 into 4.5 deep. Yeah, and the overall length of this bush is 33 mm. Yeah, so we will see that. Okay. Yes. Select the plane. It's better that you go with the front view plane. Offset it by 12.5. Okay. We can, anyway, it's a cylinder. We can do it by different methods. First, basically, we need a cylinder. So they trim the unwanted lines. Now, if you look at this lower line has got this, I mean, total distance of diameter was how much? 30, no, 12.7, if I'm correct. So that inner diameter, and over here is the above line is the outer diameter. Yeah. Yes. Revolved protrusion. So we need completely in cylindrical in shape. right? Now we'll go for one more thing is for uh, a plane that we'll be drawing parallel to this plane of selection, that is the front view plane, because we have to perform, we need to give a groove onto this cylindrical surface. So in the one of the assembly drawings in the previous classes, I had mentioned how to do this, right? Because there also uh, we need to use this parallel plane or offset plane because we cannot do any kind of drawings or cutting or protrusions from a cylindrical surface directly. Okay, we have to make use of a plane. So we'll keep it at 9 mm distance because uh, the total diameter is 18 mm. So radius is 9 mm, right? So once if I place a plane from here at a distance of 9 mm, then I'm at the circumference. Okay. Right. Okay. So they had given a groove for 2 mm width and zero point 0.5 mm. Okay. 2 mm width and 0.5 mm. So trim the unwanted lines so that we get uh, oil groove shape. Okay, this particular shape that is what we need, and this has to be. Uh, we have to go for cutout for 0.5 mm. Cutout. Select the sketch. 0.5 mm, which they have clearly given in the drawing. We have to create a hole. Go for parallel plane. Have the plane once again at that same offset plane at 9 mm distance. It's a circular hole of 2 mm diameter. Save this drawing. Yeah. And if you look at this drawing, I'll show you one more thing. So now here, just a second. Yeah. Now if you look at this drawing, there is going to be only one groove and with one single oil hole, and you can look at that in the side view over here. That has been there. Okay, we don't have any other hidden lines over here in the side view. That means this particular portion is there only in one place. Okay. Right. So now we'll go to the next part. Okay. Part is going to be what? Number 3, right? Which is going to be the stud. Okay, which has got M10 thread. Okay, so length is 55. This threaded portion on one side it is for 15 mm, other side it is for 18 mm. Okay, there is a oil hole of diameter 2.5 on one side and another hole of 2.8. This is for this 2.8 mm diameter is for the split pin to be fit. Okay, we have to put the split pin inside this hole, and this 2.5 mm diameter hole is for the oil. Okay. So anyway, it's basically a cylindrical portion. You not have to do such a complicated one. Many methods are there. Go for thread. Okay. And then so here we have on one side for a distance of 15 mm the thread, and to the other side M10 thread for 18 mm. So anyway, it has to be a through hole. So directly from the center, when you draw the circle from the plane, it is going to be, that means at the center of this cylindrical portion. So we can extend it on both the sides, which will be seen now. So here you can see the hole is at the center. That means on the plane and the circle. Now we can select both of them and go for cutout. Use symmetric extend. Okay, so we'll go to the next part, which is part number 4, the pin. Okay. Part number 4. Yes, it is over here. It's a simple part. Here we have okay. It's a cylindrical piece of 2.5 mm diameter, 24 mm. Okay. The next part. Uh, Part number 5, which is the bearing brass. So that we have it here. Yes. Right. So it's a semicircular portion, not exactly semicircle. If you look at this drawing carefully, if you look at this drawing carefully, the center for the semicircular portion is over here, but this bearing brass starts from a distance of 1.5 from the center line on both the sides. Okay, so it's not exactly semicircular, almost semicircular. Okay. and it's got the outer radius 56, then inner radius at 48, and then one more at 41, right? And there are certain groovings also, right, for which it looks like this. If you look at the other view of this brass, it is going to look like this. So it's got a total width of 39, and this particular shape here, this particular line is for 33 mm. Okay, and there are groovings for this. So that is what has been shown over here uh, in sectional view, how they look like. Okay, and there's a oil hole. Two oil holes are there of sorry, three holes of diameter 2, and there's a oil groove of 3 into 1 mm deep. So the width is 3 mm, okay, and 1 mm deep, right? To get this particular shape, it is not always required that we have to draw only in this method, okay, right? We can also do it in a much more simpler method. Anyway, we know the overall length of the line, which is 39 mm, and then the shorter line for 33 mm, right? And its distance also we know. Let's now go for revolve protrusion. For yes, this is that 48 mm diameter line. So there is another thing that they're given is that Here, look at the drawing carefully. They're given 90 degrees, and with that, there is this oil hole that has to be done. Okay, so that is why they're drawing it at this two lines, which looks like a V shape. Okay. So this is going to be done for to form that circular grooves. This is for the groove that has to be formed, which has to be perpendicular to the already formed one. So instead of making it once again onto this curved surface, you make use of pattern and rotate it so that we get the screw at the required location. Yes, now they are doing that 1.5 mm distance from the center of this arc. It should be cut throughout. Okay. There has to be an oil hole. Right. So here, next we'll go to part number 6. That is the distance piece, which is over here. So it's got this particular shape. Overall length is 33 mm. Okay, and we have to draw this. Thickness is for 3 mm. Right, and if you look at it, just a second. This section BB. Okay, it's not for that. All right. Okay, they've given only the front and top view for this. Right. Just a second. Right. Okay. Yeah. All right. So now we'll go with the next part. That is, as I just showed you, the distance piece. Okay. So we'll select the front view plane only. Now trim these unwanted lines to get the required shape. They have gone in this everything through only by drawing lines parallel and offset methods, and then trimming off the uh, uh, unwanted lines to get the required shape. But it is not necessary that we have to do only by this method. Yes, the what has been done on this particular right side can be mirrored onto the left side, and only a small portion can be trimmed now. Right, so protrude it for a thickness of 3 mm, symmetrically extend it. There is a hole of radius 10 mm at the center of this.
Sir, radius how much, sir?
Radius is 10 mm, they've given it over here.
Sir, then diameter should be 20, no, sir?
1 second. Sorry, diameter is 10.5, not that, sorry. Sorry, I made a mistake. Uh, I just misread it. So this is a diameter of 10.5. Okay, right. So this radius is 10. Yeah. Okay. So after this distance piece, the cover portion is a complicated one. The IC connecting rod and cover portion that we'll see later on. Okay. Then is the washer. It's a washer. Uh, the diameter of that part number 8 uh, is over here. Yeah. Outer diameter is 17, inner diameter is 10.5, thickness of that is 3 mm. So we can draw two concentric holes and if at all, and we can just protrude it once for all. You do not have to go in for two operations like protrude it and then cut out and so on. Yes. Yeah. So that's about the washer. And then 9 is a nut, which we all know how to do a nut. Yeah. And the split pin is there. That's also a simpler part. It's over here, part number 10. Yeah. And so that almost all the parts of the connecting rod will be done. And then will be two major portions, that is the connecting rod and the cover for the connecting rod has to be done, which is a complicated one. Okay, we'll do that. Okay, now practice these drawings. Okay, practice these drawings, right? Uh, yes, so yes, NC attendance, Madhu P, Madhu, Naman Shivananda,
Present, sir.
who's that?
Naman, sir.
Okay, yes, Shrikant, Shrikant absent. Parthasarathy,
Present, sir.
Rahul Rathod, Rajat Patel,
Sir, present, sir.
Reni Sibi absent, not there. Rohan Unikrishnan is not there. Shreyas is also not there. Samar,
Present, sir.
yeah. Sam Govardhan, yes. Next, Sayatan Banerjee,
Present, sir.
Shashank KS,
Present, sir.
Prashak MB,
Present, sir.
Shivkumar Patel, yeah, not there. So Sri Harsha Prasad,
Sir, present, sir.
yeah.
Present,
Shubhankit
sir.
Singh, Shubhankit Singh, right? Yes. So practice these drawings.
Sir, 22 present, sir.
Okay.